This video is to help you guys understand wiring diagrams. Technically, power flows from negative to positive, but the diagrams are drawn from positive to negative. I will be covering things in that manner. I need to say this because the internet trolls have nothing better to do than ridicule every video everyone ever makes. When you're diagnosing a component in a diagram, the first thing you should do is locate the component. This video will be for a horn diagram for a 1996 Chevy Silverado. We will first locate the horn. You will see the horn circled in red. Next, we will locate where the horn gets its power. It is the 20 amp mini fuse. You notice the fuse box has a dashed line around it. This is because it is incomplete. This means everything in the diagram that is in the fuse box is not in the picture. Next, we will locate where the horn gets its ground. If you look at the bottom of the diagram, it gets its ground is located at G101, located in the front of the vehicle. The lower the number, the closer it is to the front of the vehicle. So 101 would be in the front of the vehicle. 201 would be a little further back. 301 would be further back towards the back of the vehicle. Then we're going to locate what controls or sends power to the horn. It is a switch inside the relay. The relay has a solid line around it, meaning all the wiring for the relay is in the diagram. Power flows from the orange wire to the green wire when the switch closes. This is from C3 to D1. Now, we locate what controls the relay. There is a button on the horn that, when applies ground to C1 of the relay. So when you press the button on the steering wheel, it applies ground to the relay. This activates the relay. The coil in the relay is an electromagnet. When the electromagnet energizes, it pulls on a spring-loaded door in the relay. This door moves over and closes the switch. This applies positive power from the orange wire to the dark green wire. With the switch closed, the steering wheel ground is applied to the relay coil pin C1. Positive power flows from the orange wire through the coil relay. This pulls the relay closed, and power flows from the orange wire to the green wire to the horn. The horn is grounded at G101, and the horn is activated. Now that we understand how the circuit works, we can diagnose it. The first scenario we are going to talk about is a horn that honks all the time. There are two possible causes for this to happen. Number one, the black wire that is hooked to C1 is getting ground all the time. This could be a shorted wire, or the horn button could be stuck closed. Number two, the switch in the relay could be stuck closed. This happens when the contacts become welded. Now let's talk about a problem where we press the horn button. The relay clicks, but the horn does not honk. The first thing I would do is pull the relay out. Place a jumper wire across the relay contacts from pin C3 to pin D1. If the horn honks, replace the relay. If the horn does not honk, you need to check battery positive power at the orange wire. This would not be the fuse because the relay cannot click if the fuse is blown, because it also gets its power from the 20 amp fuse. Next, I would have someone hold the horn button and test for power at the green wire. If there is power, there is either G103 is bad or the horn is bad. Just put a test light across pin 1 and 2 of the horn connector. If it is lit and the horn does not honk, it is bad. Now we're going to talk about a horn that the relay does not click. Well, first I would recommend hooking a test light across pin C1 to pin D3. Then press the horn. If it illuminates, the relay coil is bad. If it does not illuminate, check power at D3. If no power, check the fuse. If it's not the fuse, then it's the orange wire. D3 is good. Most likely your ground is not applied to C1. This could be a broken clock spring wire, a broken black wire, or a bad switch. Thank you.